Troubleshooting heating and air conditioning systems can seem pretty overwhelming in the beginning. When you think about it, you have all these different brands that might wire things a little differently from one another. Each brand has all these different models, which can be wired a little differently as well. And if that's not enough, you have all these brands that have been going through these evolutions over decades of technological advancement that complicates it even more. So how do we tame that? Let's walk through a scenario service call, and I'm going to share with you the 3 weapons that we can use that helps tame all of this and make sense of it. You head out to a no cooling call. The customer says the air is blowing out of the vents, but it's not blowing cold. You decide you're going to go out to the condensing unit, and it is completely dead. It's not doing anything at all. So you take the panel off, you look at the contactor, and you notice the contactor's not pulled in. You test for 24 volts, you don't have it. What's your next move? Now don't worry if you didn't have an answer. It was kind of a trick question anyway. Sequence of operations, a schematic, and your multimeter. These 3 tools, you can diagnose problems that are highly unusual, sometimes on systems you never even worked on before, and in some cases you can even start diagnosing before you even show up on the job. That's how effective these tools are. So let's back up a little bit. So the customer calls the company, says their air conditioning isn't working, it's just blowing warm air. Dispatch conveys this information to you, and with this information you already have what you need to begin diagnosing through the sequence of operations, long before you even dispatch to the job. Let me show you how it works. So the 2 key things we know here is that the system is not cooling and it's blowing warm air. Now let's take a look at the cooling control circuit sequence. Our power starts off at a 24 volt transformer. That 24 volts then goes to the air handler control board, goes through a 3 or 5 amp fuse. From there it goes to the R terminal on the control board, goes up to the R terminal on the thermostat. When the thermostat calls for cooling, it activates the Y and G terminals. It sends that 24 volts on both those wires. And those 24 volt signals go back to the air handler control board Y and G terminals respectively. Now this turns on the indoor blower of the air handler. The signal then travels from the Y terminal on the control board to the contactor in the outdoor unit. And that's the device we find is not getting 24 volts right now. Once it goes through the coil on the contactor, it goes back to common on the air handler control board, which then goes back to common on the transformer. And once that circuit is fully complete, our contactor will receive 24 volts and it will pull in and turn on the outdoor unit. But our outdoor unit is not doing anything, and as we discovered, we do not have 24 volts at our contactor. So just by understanding this sequence, knowing the system's not cooling, we have a pretty good idea the outdoor unit may not be running properly, and we know the blower is blowing, so we know that we're reaching at least up to step 6 in our sequence. So when we showed up, that's why we went out to the condensing unit. I've been out on countless calls that all started exactly the same way. I knock on the customer's door, just confirm the thermostat's still in cooling mode, and I tell them I'm heading out back to the condensing unit. Some cases, I never even step foot in the house. Earlier in the video, when I asked what would be your next move, a lot of people would have said, go back into the house, go up to that air handler, see if you got 24 volts on this Y terminal. Now that is a perfectly logical and reasonable next step. However, today's problem is a little unique. And if you had gone up there, you would have found 24 volts on that Y terminal. Now this would have led a lot of people to think we might have a problem with that wire between the Y terminal on the air handler control board and that contactor. So now you're ohming it out, or you're doing continuity tests and you're not finding any problems. And this is where schematics can really step in and save you from all this wild goose chasing and give you a definitive answer on what your next step should be. So here's a schematic you might typically find stuck on the inside of the electrical panel that we took off on the outdoor unit to see if our contactor was pulled in. Now the first thing I always look for whenever I'm looking at a schematic is where does the power come into this unit. In most cases, a schematic, where the power comes in will be these lines just kind of hanging out in the middle of nowhere, and they don't seem to be going to anything. So let's zoom in a little bit and I'll show you what I mean. You can see these two red highlighted lines there, L1 and L2. That is our high voltage coming into the unit. So that's our 208 or 230, 240, whatever it may be, that actually powers the compressor and the condenser fan motor. But the contactor has to pull in order for that power to get in there. If you take a look at the schematic, where would you see the low voltage coming in? It's up in the corner here, up top. Now these are your low voltage control signals. That's the 24 volts that we need at our contactor. So this particular schematic is a two-stage cooling system. You can see we have Y1, Y2. We have a common. If you see the notes, it says right here on the schematic, it's to the indoor unit low voltage terminal block and the indoor thermostat. That is the voltage coming in from our steps 5 and step 6 that we covered earlier. Now Y1, that is our first stage cooling. That's what initiates everything. So if we follow that line, we see the schematic is telling us it's a purple wire. And if we follow that purple wire, it comes up to that little triangle that is a wire nut. And that purple wire connects to a black wire. Now what the schematic is telling us is that there are other things going on in this circuit prior to it getting to the contactor. So if we were to take that wire nut off and test to see if we have 24 volts there, what do you know? We find 24 volts. So what do we do now is we have to find the next component in this circuit. Now this component here labeled DT, that is a discharge thermostat. If you see abbreviations like this, you can look at the legend, it'll tell you what it is. Now a discharge thermostat, if you're curious, it just monitors the temperature of the refrigerant at the compressor of the unit itself. So if the refrigerant gets too hot, it shuts the unit down by preventing the 24 volts from making it to the contactor. If we were to now take our multimeter and see if we had 24 volts across this switch or no volts, that could tell us whether or not this switch is open. So if we measure 24 volts across both of these terminals, that's telling us we have an open switch. If we measure 0 volts, that means the switch is closed. So what we're reading right now is 24 volts, which means we now have an open switch. So we now have to start looking at the refrigerant levels, maybe the compressor. But basically the whole point here is that you can see how the sequence of operations kind of points you in the right direction. Schematics can help you zero in on where the problem actually is, and the multimeter can kind of help you close the deal. Now all technicians that have been doing this for years, they're always using these three tools plus the fourth one, which is just listening to the customer. So all these tools together are the things that actually lead technicians to quickly and correctly diagnose problems without running around everywhere doing continuity tests up in a 140-degree attic when the problem is outside near the compressor. So we're going to find ways to keep utilizing all these tools with every lesson I keep putting out there moving forward. If you're interested in any of these lessons, you can follow the link below in either the pinned comment or description box. It takes you to a whole playlist of all these lessons. They are completely for free. I'm not charging anything for them. So hopefully we'll see you guys on the next one.